All right, guys, let's get started. Thank you so much for joining, and good morning and good evening to everyone. And thank you so much for taking the time on a Saturday morning or evening, based on where you are with us. I know it means a lot. My name is Patrick. I'm one of the developers and course creators at HadoopInRealWorld.com. Okay. So before we dive into the session today, quickly tell us where you're from, and and if you have already registered with registered for a course with us, whether it could be a developer course or an admin course, just give us a shout. I'll pause for maybe a minute or two just so I can collect all the responses, and then we can go from there. Okay. All right. We have people from New York City, from Thailand. Let's wait for a few more responses. All right. I think it is safe to assume we have people from many different places joining. From east, west, I think from all over the world, and we're live streaming on YouTube. So it is safe to assume we have a lot of people joining from different places around the world. Today the reason for the live stream is to launch our Hadoop Administrator in Real World course. And if you have already pre-ordered the course, thank you so much. We were very happy with the response that we got during our pre-order phase. So thank you so much if you have already brought the course. Um, just to take a step back, November 2015, when we came out with our Hadoop Developer and Real World course, we got tremendous response. People were very happy with the content they were receiving because it was tailored more towards what developers would do in a Hadoop cluster on a day-to-day basis. So, a few months down the lane, we got requests asking for administration-related courses, right? So that's when we decided to make an administration course. So very soon after we got a lot of requests and we decided to make an administration course, we made out a list of items that every Hadoop administrator should know on a day-to-day basis, so that they can be efficient in their job. And also, it's the list of items that employers expect every Hadoop administrator must know. So then we looked at other courses in the market, what other courses basically cover in the market, and we were really shocked to see most of the courses out there a touch on installation, starting and restarting services, and a couple of random topics, right? We were not very, it was really shocking because, Hadoop administration is not just installation and restarting a couple of services. Okay, so Hadoop administration is more than that. So we wanted to cover all the topics which would help administrators in a real Hadoop production cluster to manage and administer the cluster with confidence and also, stress-free maintenance, right? Because Hadoop clusters are usually chaotic because you're trying to manage hundreds of nodes, in some extreme cases, even thousands of nodes. So we wanted to give the administrators a peace of mind so that, they know all the concepts, they know all the pitfalls and things like that. So that's what we really wanted to focus in our Hadoop Administrator in Real World course. Okay. All right, we got requests, a lot of responses coming in. We have people from India, we have people from Dallas, we have people from, again, India, and people are saying they have enrolled in both dev and admin courses. Thank you. And yeah, Murali from India, thank you so much. You have registered for both admin and dev courses. Thank you, thank you, thank you. Thanks a lot. Okay, so here's the game plan for today. Okay, so we're going to talk about cluster sizing. And actually, this topic was decided by you, that is the Hadoop and Real World community. Okay, so a couple of weeks back, we said we're going to do a live stream, and we gave you a couple of topics. Cluster sizing was one of the topic, and recovering data from accidental data loss, that was another topic. And you guys decided you wanted to we wanted to do a cluster sizing topic. Okay, so you pick cluster sizing, and that is exactly what we're going to cover. And once we finish focusing on the cluster sizing topic, we'll quickly go over the contents, the course contents of Hadoop Administrator in Real World. And also the pre-order ended yesterday. We said the pre-order pricing of $99 would end yesterday, midnight, and it did. And we got few emails, actually quite a few emails this morning, asking for the same discount. So we have some good news for those who missed the discount. For this weekend, until this weekend, we are extending the discount. So I'll let you know the details of how you can get the course at the pre-order price just for this weekend. So stick around. I'll give the information about the discount at the very end. Okay. All right. So before we start on the cluster sizing topic, just a quick introduction about Hadoop. I know we have people in the live streaming right now who's experienced in Hadoop, and some people who are just starting with Hadoop. So I just wanted to give a quick introduction about Hadoop. Okay, so this is going to be very short. This example is going to stick with you. Okay, so what is Hadoop? So let's take a step back, like centuries back, maybe. When our great ancestors, when they are farming in their farmlands, right? They were using oxen or bulls or animals to get the job done. That's where they were using. So when the workload is huge for those animals, what did they do? Right? Did they went ahead and built a bigger animal? No, they didn't. They added more animals to the pack, and that's how they get the big job done. When the workload increased, they added more animals. They added more oxen, they added more bulls or whatever, right? So like fast forward, what did we do from the technology standpoint when our workload get bigger, right? What did we do? we added we didn't add more machines, we built bigger machines. Okay, we built bigger machines. I think that's that's like rationally somewhat wrong. I mean, we spent a lot of time building bigger mainframe machines instead of focusing on how to distribute this job much better. In the last decade, we have made so much progress with like open source communities like Hadoop, Spark, and things like that. We have started truly distributing the workload. Okay, we've started truly distributing the workload, and that is a very good thing. So Hadoop basically um, handles workload, or when the workload increases, you can use Hadoop, and which is in a truly distributed fashion with thousands of nodes working together. And these nodes are all simple, regular nodes like CPU, memory, and some hard disk. There is nothing special to it. These are beefier machines, sure, but these are regular day-to-day CPU, RAM, and hard disk machines. Okay. So instead of instead of investing a lot more time on building bigger mainframes, sophisticated hardware, and a lot of expensive hardware equipments, we took what is the core, that is a simple CPU, hard disk, RAM concept, and we multiplied it, and we distributed the load accordingly. Okay, so that is Hadoop in a very small example. Okay. All right. So now the most important part about Hadoop administration is cluster planning. Okay. And what is cluster planning? Cluster planning is all about choosing the right vendor, uh, deciding on the software requirements, deciding on the hardware requirements, the number of nodes, network topology, etc. It's not just one thing; it's a collection of things. Okay. And it is a very important concept for every Hadoop administrator to understand and to even master. Because you, as a Hadoop administrator, could go in to a job and they might have a big Hadoop infrastructure already in place, right? Well and good. So you go day one of your job, you go start managing the cluster. But what if you were asked to design a cluster from the scratch? At that point, you need to know which vendor should you go with, which switch, what are the software requirements, what are the hardware requirements, the number of nodes, which network topology you choose, etc. Right? And that is why it is very shocking for us to see other courses and other materials out there doesn't even touch on this topic. This is a very important topic. Okay, and that's why we have a separate chapter covering cluster planning in the Hadoop Administrator in Real World course. So in today's cluster planning session, we're going to just not cluster planning session, but cluster sizing session. We're going to talk about how many nodes do we need in the cluster, and what kind of hardware configuration do we need in the cluster. Okay. So before we talk about how many nodes we need in the cluster, let's take a step back. Okay. Let's take a step back and ask ourselves, what is the hardware requirement that is needed on your cluster? For that, you need to know what kind of jobs and how the cluster will be used. Are you going to use your cluster for more storage and I/O intensive operation, or are you going to use the cluster for more compute intensive operation? Right? So we need to answer that question first. Right? So let's talk about what is storage intensive operation and what is compute intensive operation. Okay? Storage intensive operation meaning you will have a lot, of course, you will be dealing with a lot of data. That's what Hadoop is. Hadoop is a big data environment, so you will be using a lot of data. But you will be, with the storage intensive operation, you will be moving the data back and forth between nodes, which means all your operations are I/O intensive. You will be reading a lot of data, you will be writing a lot of data, and you will also be transferring data to and from the network quite a lot. Okay, and the examples, specific examples for storage or IO intensive operations are indexing, searching, grouping, data ingestion, and any kind of transformation you do with the data. Those kinds of jobs are typically storage or IO intensive jobs. Okay, now let's talk about compute intensive jobs. All right, compute intensive jobs, you could deal with a lot of data, but most likely with compute intensive jobs, your data volume is slightly lower when compared to the storage intensive job, but you will do a lot of calculation and manipulation on the data. So the data movement in a compute intensive job is lower. Okay, you won't be moving, reading or writing a lot of data between the network. Okay, so that is compute intensive jobs. So some of the examples are classification, data mining, language processing, and artificial intelligence. So those are the typical examples of a compute intensive jobs. All right. So depending on the type of job, you have to decide on the hardware requirements. So you have to decide on the hardware requirements depending on the type of job. So whether it's storage intensive or IO intensive, once you decide on that, your hardware requirement could vary. So you can ask your development team and you can ask your product owners what kind of problems they are trying to solve with Hadoop. And you can ask them, are you trying to do a lot of storage operations like IO? Are you doing a lot of CPU cycle operations like compute intensive jobs, right? So they are going to tell you it's either storage or compute, and sometimes they will say it is a mix, right? But if you get an answer like all we are going to do is all our jobs are going to be compute intensive, you don't want to decide a cluster based on that answer, because at the beginning, when before there is a Hadoop production cluster, whatever your development team, the use cases they have, they are all very immature or at the very early stage. So as they start using the cluster, the use cases will definitely change. Okay, so right now they could say they're using storage intensive job, but later they could use the cluster for more compute intensive operation. The same goes the other way around. Now they could say we want the cluster to execute storage intensive job nicely, but a year from now they could execute a lot of storage intensive jobs. So when you think of designing a cluster, you should think of a balanced configuration. Okay, you should always, as an administrator, your job is to look in the future and look for a more balanced setup. All right, so let's talk about hardware configuration next. All right, so this is this is more of a suggestion from Cloudera. Again, there is no magic number, there is no magic formula where you can punch in this is what I want, and someone is going to tell you this is exactly the configuration that you need. That ain't going to happen. Okay, that is not going to happen. So when we talk about hardware configuration, there are three elements we need to consider, right? One is CPU, the other one is RAM, the other one is hard disk drive. There is also like Ethernet card, network topology, and all that, but let's leave that aside for now. Okay, so let's just talk CPU, RAM, and hard disk drive for hardware specification, right? So Cloudera has classified the specification into four kind of classifications. For a light cluster, meaning light jobs, it could be on the storage side or compute intensive side, but the intensity of the jobs, they are on the lighter scale. Okay, then comes the storage intensive job. You do a lot of storage related stuff, IO, as we spoke about. Then in the middle comes the balanced approach. Okay, your specifications are balanced for both storage and compute intensive. All right, and finally the compute intensive. So for the CPU, they have suggested 2 hex core for everything, although we disagree. Okay, for a compute intensive, you could go hex core or octa core even fine, but but for storage intensive, you could go with couple of quad core CPUs, and that is okay too. All right. So for RAM, that's where that's where you would see a lot of difference between storage and compute intensive. Let's keep the light specification aside for now. Okay, let's talk about the storage intensive specification first. The RAM is 48 to 96 GB. right? And if you look at the compute intensive, the RAM is higher when compared to the storage intensive specification, which is 64 to 512 GB. All we're talking is per node, okay? And you're thinking, wow, these are, these are like beefier systems. And yes, they are beefier systems, okay? They are beefier systems. So storage intensive, the RAM, as you can see, they are lighter when compared to the compute intensive, which starts from 64 and it can go all the way to 512. Because when you do computational operations, you need a lot of RAM because you will be doing a lot of computation in memory so that your computation will be faster. Okay. Now let's talk about the hard disk drive. Again, the light configuration is probably 8, 1, or 2 terabytes disk. Okay. So if you choose 8 1 terabyte disk, you have 8 terabytes of hard disk space in one node. Again, we're talking just one node, not a whole cluster, okay? We're just talking one node. So now let's talk about storage intensive um, specification for hard disk drive, okay? 16 to 24, 2 or 4 terabyte hard disk, okay? So if you choose 16 2 terabytes of hard disk space, you have 32 terabyte of hard disk space in one node, okay? Compute intensive compute intensive for HDD is very low, as you can see. We're talking about 4 to 8, 1 or 2 terabytes, even lighter than the lighter specification. Because because we have more RAM and less hard disk space, because this cluster or this node is going to be used for a lot of computational related stuff. So that's why lighter on the hard disk space. Okay. Now, if you look at the balance configuration, it is very good. It sits in the middle between storage intensive and compute intensive. So here the RAM space is 48 to 128 GB, and the hard disk drive is 12, 1 or 2 terabyte of hard disk, okay? So you can either go with 12 1 terabytes or 12 2 terabytes. If you go with 12 2 terabytes hard disk, you'll have 12 hard disk space, each with 2 terabytes of capacity, so your one node can accommodate up to 24 terabytes. Make sense? Most typical configuration are balance configuration, and we ask administrators to shoot for the balance configuration. All right, and why? Because right now you may think you're going to do a lot of computational related tasks, but a year from now you wanted to do a lot of storage related tasks. That's why, okay? So in one of our recent engagement with a client, we saw our client was using 2 hex core, 24 GB of RAM, and 12 terabyte per node. 12 terabytes per node. So that's the configuration. That's the typical configuration, and you can go up or down. And as you can see here, you could probably think, when you heard about Hadoop, you heard that Hadoop is based on commodity hardwares, and you could probably think, what is commodity about it, right? Because these are beefier systems. Yes, they are beefier systems. Okay, but there is no specialized hardware involved in the system. Yes, they are big, but there is no special hardware involved. Got it? Okay, it's just based on 3 elements: CPU, RAM, and hard disk drive. That is it, right? You're going beefier on the systems. That's all. Okay. Now, let's talk about the number of nodes. Now, let's say you, based on speaking to your, development team and also the product owners, you decided you're going to go with a balanced configuration or balanced specifications for your node. Perfect. Now, how many nodes do would you need in your cluster, right? And that's where the data ingestion comes in play, right? So let's talk just storage for now, and then let's talk about the computational aspect, right? So now we need to know how much of data you're planning to store in the cluster, and that's why you need to know the data ingestion rate. As an administrator, you won't know what is the data ingestion rate is, so you have to speak to the development team. And let's say the development team comes back with a response saying that our data ingestion rate is going to be 1 terabyte per day. So given the data ingestion rate is 1 terabyte per day, and with the replication factor is 3 terabytes per day, let's say the replication factor is 3 terabytes, right? Because in Hadoop, if you don't know about the replication factor, each data block is replicated 3 times for redundancy, and this is truly for redundancy. You can tweak this number, you can go lower or you can go higher, but 3 is the default, and 3 is where almost all production um, installations would go with. Okay, so with the data coming in at 2 terabyte per day, and with the replication factor of 3, you're looking at 3 terabyte per day of storage. Okay, now if you extrapolate that number for 365 days, you're talking about 1095 terabytes per year. Okay, and let's add 25% on top of it. Okay, so and that is for non-Hadoop or non-HDFS usage. All right, this 25% is for non-HDFS usage, and 25% seems like a big number for 1095 terabyte, and of course it is a big number for 1095 terabytes. But if you're talking 1 terabyte, 25 of 1 terabyte for non-HDFS usage is very low. But again, 25% of 1095 terabytes is very high. So you have to choose somewhere in the middle. You need space for non-HDFS for your OS, for your local file system, for your installation files, for your log files, for your day-to-day stuff and things like that, right? So that's where the non-HDFS space is going to be used. So if you add, let's say for this discussion, plus 25%, you're looking at your cluster to store 1,350 terabytes of space. Okay, 1,350 terabyte. And that is for a year, right? So 1,350 terabytes of storage space per year. Okay, so now let's say you have a balanced spec, right? And you have in each node you have 12 2 terabyte of hard disk space. That is 24 terabytes per node. Okay, you have 24 terabytes per node. Let's take the 25% out because that's non-HDFS. Again, 25% of 24 terabyte is a lot for non-HDFS. But for the sake of discussion, let's say 25%. Okay, so we're going to talk about 18 terabyte per node. That is just pure HDFS space. So to store 1095 terabytes per year, okay, and 18 terabytes per node, we are talking about 61 nodes. So we're talking about 61 nodes. So for a data ingestion rate of 1 terabyte per day, and with the node with a capacity on each node with capacity 12 2 terabyte, that is 24 terabytes, we are talking 61 such nodes, to handle the full capacity. Okay, makes sense, right? 61 such nodes. So now you can say, I want to, can we go 12 1 terabyte hard disk, which would make it 12 terabyte per node, and can we go 122 nodes? You can double the nodes. You can reduce the hard disk size and you can double the nodes, but we will advise against that. Okay, and let's see why we say go with beefier nodes rather than lighter and too many nodes. Okay, so let's say you're shopping for a laptop. You're comparing two laptops, okay? A 4 GB laptop and an 8 GB RAM laptop, all right? So a 4 GB laptop is going to cost, let's say, $500, and an 8 GB laptop is going to cost 600 or 700 bucks, not 800 bucks, not double the memory, not double the price just because you double the memory on your RAM. Makes sense, right? Because just because you're doubling the memory, the price doesn't double. But if you go lighter nodes and a lot of nodes, your cost is going to double. May not actually double, but you see there will be a significant increase in the cost. So we always suggest go with beefier nodes and less number of nodes. Okay, it has to be there has to be a balance that has to be struck here, right? And also, if you have too many nodes, there are other logical issues, logistical issues with it. Okay, now we have to store these too many nodes into a data center, right? Which means you need to lease rack space for these extra nodes. When you add more rack space, you need to add more cooling. You need to add more power, everything, the maintenance of the cluster. As an administrator, you have to install software on double the nodes now. It's a nightmare. So always go with beefier systems rather than choosing lighter systems and too many nodes. So beefier systems with fewer nodes rather than lighter systems with too many nodes. Okay. All right. Now, so far we discussed about the hard disk space, right? So we decided the number of nodes based on the storage capacity, based on how much data we are going to ingest. Now let's talk about the computational side of things, right? How many jobs you can run. You can also go or angle your cluster sizing from how many jobs you want to run at any given time. Okay. So Hadoop has a map reduce component. Those of you who don't know, the map reduce component has two elements to it, mapper and reducer. For a job will always have multiple mappers and fewer reducers. So it is not uncommon to have like 100 mappers in a job and maybe one or two reducers for that same job. Okay. The mappers does some computational stuff and they send the data to the reducer. The reducer aggregates all the data from the mapper. That's like map reduce in a minute. Okay, but let's say for each mapper requires 2 GB of RAM space. Okay, and for each reducers require 4 GB of 4 GB of RAM. Okay, so let's also assume the memory in each node is 64 GB. Okay, so each node has 64 GB of RAM space. And memory available for Hadoop, let's assume is 50 GB because you need to allocate some memory to your OS kernel, other OS operations, other non-Hadoop process, etc. Right? So let's say the available memory for Hadoop is just 50 GB. 14 GB is allocated to your OS and the other process. So in this setup, and each mapper requiring 2 GB, right? The number of mappers that can be executed in a node simultaneously is 25. Make sense? So you can execute 25 mappers at a time in one single node. Now, let's assume you have a job with 1,000 mappers, okay? And with 1,000 mappers, and if you want to run 1,000 mappers in your cluster at a given time, and 25 mappers per node, you would need 40 nodes. Make sense? You would need 40 nodes, right? And we are just talking about mappers here, right? We haven't talked about reducer. Of course, in a cluster, mappers and reducers will run together at any given time. It is absolutely possible, and that's how it will be, right? And there will be multiple jobs running at the same time, right? So coming up with the number of nodes based on your computational requirements is harder. It's very hard. It's very hard. Okay. Yeah, it is easy to it is easy to think the storage from the storage point of view and decide on the number of nodes. You can pretty much get to a pretty accurate number. Okay, but from the computational angle, it is very difficult. Because you're making a lot of assumptions here. You're assuming your mapper would only need 2 GB of memory. Okay, and it could be more, it could be less. We don't know until the use cases are developed and the jobs are actually being executed on a live cluster, right? Here, what you're trying to do is, again, as I was saying before, right? We are working on a lot of assumptions when we are sizing the cluster, and that is the reality of it. There is no formula where you can punch in some some numbers and some specs, and you will know the formula will spit out the exact number of nodes. That is never going to be the case. Okay, so that is never going to be the case. So let's get that out of the way. Okay, so you have to, whatever decision you make, you have to document your decisions. You have to document the rationale behind those decisions, and you also have an open discussion with your product owners, with your development team, and also with the management team. for why you're making some decisions, why you think the number of nodes is going to be this, and why not this, and all that. Have an open discussion so there are no surprises at the very end, right? And also, just one more point, you always have to have the growth in mind, right? You're designing the cluster today, but the cluster will be used for years to come. So that's why it's very important to go with the balanced configuration, and that is also it's also very important to think about the storage growth in mind, the computational growth in mind, and all that, right? So don't design a cluster just for today. As an administrator, you should have a future vision in mind. Okay. All right. So that is about the excuse me. So that's all about the cluster sizing. So now we saw what are some of the specifications of the node could be, what are your options, when it comes to hardware specifications, and with some hardware assumptions and with some storage ingestion rate assumptions, we can arrive at the number of nodes. We saw both from the storage point of view and also from the computational point of view. Okay, so and also, some of you, I'm also watching the stream, and some of you are experiencing the buffer, and it is very common with with YouTube Live, where you have some buffering. So I'm going to move on to the next topic, but type in your questions, and at the very end, I'm going to come back to your questions, and I'm going to answer the question. But since we have buffering, I'm going to move on to the course coverage, but I will definitely answer your questions at the end. Okay, but feel free to use the chat to type in your questions. Okay, sounds good. All right. So the next topic that I wanted to cover is from cluster sizing, jump into course coverage, right? Yes, we are launching the course today. Hadoop Administrator in Real World is live. If you have the course, if you've already registered to the course, if you've already bought the course, you can go in and you can start learning. Okay, and you probably have seen us talk about course, what we have covered in the course. But for those who haven't seen, this would be a good introduction for you with respect to what we cover in Hadoop Administrator in Real World. Okay, so the very first chapter is going to be course coverage and cluster access. Pretty much, what you're going to hear, what you're going to see and hear in this. I mean, this live stream will be repeated again in the course structure lesson, and we'll also be talking about cluster access. Okay, when you enroll to Hadoop Administrator in Real World or Hadoop Developer in Real World, you will get a personalized access to our live 3-node Hadoop cluster hosted in Amazon Cloud. Okay, because we don't want our students to spend their time and effort figuring out virtual missions and things like that. We want you to move on fast. We want you to get your feet wet with Hadoop right away. Okay, so that's why we provide a 3-node Hadoop cluster access to all our students. And it is a personalized access if you're registered with Hadoop Developer or Hadoop Administrator. The access, you also get access with Hadoop Starter Kit course. That is a free course. You also get free cluster access with that course, but it has slightly less permissions than the credentials that you would get with Developer and the Administrator. And in this the cluster access lectures, you would learn how to connect to our cluster from a Windows or a Linux environment, where to see the files and things like that. Pretty simple stuff. Okay, so the next chapter is Introduction to Big Data. We assume that you have no knowledge in Hadoop. When you start any course with us, we assume you're starting from the scratch. If you know about big data, well and good, you can skip this chapter. Here we're going to talk about what is big data, what is the use case, the history of Hadoop, and given a problem, can you say whether it's a big data problem or not? Because it is very common. If let's say you're going to consult into the consulting field, and you consult for a client, and the client shows you a problem, and he's asking you to implement a solution in Hadoop. Sometimes Hadoop is not the answer. It's not the answer for every performance issue you have. It's not the answer for every data problem you have. At that point, you have to say, look, you know what, this is not a Hadoop problem, and you should guide the client in the right direction. So that's what you'll learn in the introduction to the big data chapter. The next is HDFS. Here you're going to learn what is HDFS. More importantly, why do we need another file system like HDFS? That is the core of it. Learning HDFS is very straightforward. You can learn it from YouTube and whatever. But what we teach here is why do we need another file system like HDFS? Because every operating system has a file system. If you're using Windows or a MacBook, it has a file system. So why do you need another file system like HDFS? That's what we will talk about here. We also will show you, how to work with file system, the HDFS file system. All right. So the next one is MapReduce. Again, for an administrator, you're not required to write MapReduce programs. Okay, you don't have to write MapReduce programs. On the cluster, that's the job of Hadoop developers. All right, but so why do we teach MapReduce? Because as an administrator, you need to know what is running in your cluster, and when the developer comes in and say like the reduce jobs are running slow, you need to know what is reducer and what are the phases and what happens between the map phase, the reduce phase, and what happens inside the shuffle phase and things like that. Knowing these details will help you troubleshoot performance issues and address any problems. You would have better understanding of what is going on in your Hadoop cluster. So that's what we cover in MapReduce. The next is architecture. So in the architecture chapter, we talk a lot about the Hadoop architecture in general. And we also talk about there are single point of failures in Hadoop. Hadoop is not perfect. Just so you know, Hadoop is not perfect. It has single point of failures, meaning like Hadoop system can fail. Even though we have multiple redundant nodes running, Hadoop system can fail. Okay, so we have to understand as an administrator, you need to know the failure points. You need to know how to protect the cluster against those single point of failures, and we will be talking about those in the architecture lesson in the chapter as well. Okay, so in these chapters, between the developer and the administrator course, there is some overlap. There are some overlap because the concepts are the same. HDFS concept for a developer and an administrator, they are pretty much the same. In some chapters, you will have more lessons in developer when compared to the administrator. In some chapters, you will have more lessons in the administrator when compared to the developer course. Okay. Now, let's move on. Cluster planning. Okay, so what do we cover in cluster planning? And this chapter is only available in the administrator course, not in the developer course. And in the cluster planning, along with what we saw today, like the hardware requirements and the cluster sizing, we'll also talk about versions. We'll also talk about the software requirements. We'll also talk about the hard disk design, whether you go with a RAID setup or whether you go with a JBOD setup. We also talk about a kernel level tuning and also network topology. Very important concept. Most Hadoop administrator, if I had to take a guess, like 80% of the Hadoop administrator, they don't know what is network topology and what goes behind the network. They don't know actually, what goes on behind the network. So we will be talking and discussing all those topics here, okay, in the cluster planning chapter. Moving on, cluster setup. Okay, so we also have cluster setup in the developer course, but in the administrator course, we have added few more lectures to the cluster setup. The cluster access you would get, you can try MapReduce programs, you can try HDFS, you can run pig scripts, Hive scripts, and all that. There are no restrictions. However, you cannot install anything on it because the cluster is being used by thousands of students. Okay, you cannot uninstall, stop a service, start a service. We don't want any interruption to the cluster because it is being shared by all the students, right? So how do you practice installation? How do you do start and stop services and things like that? You need hands-on too. We totally understand that. So there are two options to it. We always recommend you go with a cloud service like AWS or Google Cloud or along those lines. But there is a cost association to it. Sometimes it's not possible for spending some extra money on for a cloud vendor. Totally understand. So that's why we show you how to set up virtual machines on your laptop so that you can simulate a multi-node environment setup in your laptop. Okay, so right in your laptop you can run 2 or 3 node Hadoop cluster. Whether you're running a Windows machine or whether you're running a Linux machine or a MacBook, doesn't matter. You can using the virtual machine concept, you can run multiple nodes on your laptop or your desktop and simulate whatever we learn in the course, okay, on the cluster setup and in the coming chapters. Day-to-day essentials, very important chapter for Hadoop administrators. What do we learn in day-to-day essentials? It's basically what you do on a day-to-day basis managing a Hadoop cluster. We start from, let's say you're starting a job day one as a Hadoop administrator, and you're trying to manage a brand new cluster. We'll show you how to get information about the cluster. So we start from the very beginning. We'll talk about how to recover from accidental data loss, adding and removing nodes from the cluster, configuring your network topology of the cluster, managing your disk usage, managing the quotas, and things like that. So we cover like starting, stopping, and all that in the day-to-day essentials. It's a very important chapter. I think every Hadoop administrator should know the list of topics included in this chapter. Okay. So now, Kerberos authentication. Okay, so as a Hadoop administrator, your job is one of your job responsibilities is to protect the cluster. Agree, right? That's I don't think anyone would disagree with that. So when Hadoop first came out, Hadoop didn't have a strong authentication model, and later Kerberos authentication was included in Hadoop. Okay, so Kerberos authentication was included in Hadoop. So, not only you protect the cluster from unwanted user access, you can also protect the cluster from any unwanted or unneeded services or data nodes connecting to the cluster. Okay, so that's what Kerberos authentication is all about. And also, this topic is included in the Cloudera administration exam, which I'll talk about in a bit. The next is high availability. As I said, Hadoop has single point of failures. Hadoop is not perfect, but Hadoop committers and engineers have worked out solutions so that you can come up pretty quickly when there is a failure. You cannot totally avoid the failure, but when a failure happens, you have ways to bounce back pretty quickly. So that is high availability. And in this chapter, we talk about the single point of failure in Hadoop and how we can overcome the single point of failure with the high availability concept. Okay. So the next one is resource management. So in resource management, we'll talk about different kinds of schedulers. So what is job scheduling? So in a Hadoop cluster, again, it is a shared cluster. It is going to be used by potentially thousands of users, right? And thousands of users or thousands of jobs running at the same time, and many departments sharing the cluster. It's very common. It's a big cluster. It's a big investment. So you have marketing team funding the cluster, let's say for 60%, and the other sales team maybe pitching in the other 40% of the cluster. So how do you share resources between these two, right? So we will talk about some strategies and different kinds of schedulers like FAIR, FIFO, and capacity scheduler, which are very common with the Hadoop ecosystem, right? So in this chapter, you will learn all the strategies, how to use scheduler to your advantage to help your teams and to help the end users of Hadoop cluster access or share the cluster. All right. You'll also see how you can protect the cluster from over resource utilization and avoiding unwanted users submitting jobs and accessing key resources in the cluster. Okay. So that's what we'll cover in the resource management. Now, Cloudera Manager, right? So far, when we did Kerberos installation, when we did a cluster setup, when we did high availability and all that, we do, in our course, we show manual installation, meaning we go step by step. We assume you don't have a tool like Cloudera Manager, which is a tool which helps administrators and to manage the cluster. It is a nice user interface tool with nice charts, with great dashboards, which will help you install stop, start services and all that. But we don't talk about Cloudera Manager until the very end. When we do installation, we do it manually. That is step by step. And we have a reason, and there is a very good reason why we do that. Because Cloudera Manager is the easy stuff. Okay. When you have Cloudera Manager, installing services, starting and stopping, very straightforward. You can just look at the tool and you would know what to do. But if you know only Cloudera Manager, if you know to install and configure a service only using Cloudera Manager, when there is an issue or when your boss is asking you to tweak a property, you won't have a clue where to look. Okay, so that's why we cover the hard part first, and that is the important part, right? So when we install or when we do a cluster setup, when we do Kerberos installation or configuration, when we do high availability configuration, we go step by step. We use command lines to execute commands. We do manual configuration. We explain each and every property that goes behind that configuration. And we think that is very important. If you know that, you can handle pretty much any production issue. If your boss is asking you to change a property, you can do it pretty easily. So that's why we cover Cloudera Manager at the end. But we do cover Cloudera Manager because Cloudera Manager is widely used in the industry for managing Cloudera clusters, Cloudera Hadoop clusters, right? And we cover installation, starting, stopping, working with the cluster, monitoring, troubleshooting, and charting, and all those concepts, in Cloudera Manager. Okay. Next is tools in the Hadoop ecosystem. Okay, so here we'll talk about tools like Apache Pig, Apache Hive, Scoop, and Flume. What are they? We will also show you some sample scripts. What is Pig, what is Hive, how it's used, same for Scoop and Flume, and also installation. Again, when we talk about installation here, we'll do manual installation because the installation we do in Cloudera Manager will cover the automated part. Okay, and why we talk about tools in an administration tool? Again, as an administrator, most likely you will not be asked to create Hive tables or write Hive queries or write a Pig script or write a Flume script. You won't be asked to do that. But you need to have an idea of what is Pig, what is Hive, what is Flume, what is Scoop, and the other tools in the ecosystem. Because developers are going to talk to you about when they have issues with their Scoop script. How do you know how to suggest a solution if you don't know what is Scoop? Makes sense, right? So that is why we talk about tools in the Hadoop ecosystem. All right. So these are the chapters in the Hadoop Administrator in Real World course. All right. So and all these topics, when we go through all these lectures, we have made the course CCAH ready. Okay, that is Cloudera Certified Administrator for Apache Hadoop certification exam, right? So we have looked at all the topics that is covered in the CCAH exam, and we have included, all the topics that is needed for the exam. So the course is CCAH ready, meaning when you go through the course, you will learn all the concepts that is listed in the CCAH exam. Okay, so before I end the course coverage, I want to make an important note. That is, the course is a living course. Same with our developer course. The administrator course is a living course. When I say living course, I mean Hadoop ecosystem. It's an energetic ecosystem, meaning new tools are coming out like every month, right? And not all tools are successful and widely accepted, but some tools are getting very popular. Okay. And going forward, we'll be looking at all those tools. So for example, the next couple of topics that we want to address in our course are Spark and Kafka, right? Because we hear a lot of good things about Spark and Kafka. Our clients use it, and also our students want it because they see a lot of opportunity with Spark and Kafka in the market. So we are planning to include Spark and Kafka to both our developer and admin courses. We'll add relevant topics to each course. And um, after that, once we finish Spark and Kafka, we'll move on to Apache Ambari. Oops. We'll also cover Apache Ambari because we also have students asking about the Hortonworks framework. Excuse me. We also have students asking about the Hortonworks framework because some of the clients, of course, use Hortonwork. It is widely popular as well, and they also want to see like things like Apache Ambari and the topics that are included in the Hortonworks administration exam also included to the course. So that is what we will look into next. Okay. So when I meant live course, that's what I mean. The Hadoop ecosystem is very live. It is growing. New tools are being added in. So as new tools come out, as students ask for new tools, and based on the popularity of the tool and the number of requests, we'll add the tools and update the course accordingly. Okay, so you don't have to worry about the course being obsolete. And all the new content that would come out when we add it to the course will be available for any student who registers to the course. Okay. So now I'm going to go take a minute or two pause just to read your questions, and I'll come back and I'll answer the questions. Okay. So we're going to have a pause of maybe 1 or 2 minutes so that I can just go over the questions and just line up the answers. All right. So expect a pause for a minute or two. All right, I'm back. I've looked at the questions. There are not actually too many questions, which is okay. Which probably I think the students got the gist of what we were talking about, and it was clear. So that is a good sign. So the one of the questions was, do we get this recording, for later access? Absolutely. We are doing a YouTube live stream, as you know. So as soon as the stream is over, this video will be public. You can see it in our channel. So no problems there. And we had a quest. Yes, we had some. We have buffering issue. It's YouTube. That's how YouTube is. At least there is 1 to 2 minute buffering, which is quite large actually. Um, what do we mean by 2 hex core CPU? I mean, when you have CPU cores, is basically the number of CPUs in your system. For example, if you're talking about your laptop specification, let's say if you're shopping for a laptop, you could see something like quad core, which means like you have a 4 core CPU, which means like more multi-threading. Each CPU can do its own part of processing. So you're talking about faster processing. So that's what you're talking about there. And Debenture is asking dual core, same thing. I'm sorry, dual core is the same thing. That's 2 cores. Debenture is asking, when you say no special, what is the definition of special? Yes, good question. So when we say no special, that is the context is I said these nodes are there's nothing special about these nodes, right? That is the nodes in the Hadoop cluster. These are beefed up computers, but nothing special about them, meaning there are no specialized hardware, right? We are not talking about a Fusion I/O card or an in-memory caching setup or anything like that. Okay. For example, if you take SAN for instance, SAN is an expensive piece of storage setup, right? We're not talking SAN when we talk about here Hadoop, right? Even though Hadoop is related to storage, we don't talk about SAN, okay? Because SAN is expensive. Um, so that's what I meant by no, it's not special, okay? The next is what is meant by 2 hard disk drive in one node? Yeah, so when we go by hard disk, there is a cap. If you want a 64 terabyte hard disk space, you won't get a piece of 64 terabyte hard disk space. It is usually you will buy like 1 or 2 terabyte or 3 terabyte hard disk space or 4 terabyte of hard disk, and they will be connected together, in your rack, and they will be presented to your data node. So the node will see if you have 12 2 terabyte hard disk, it will see 12 physical drives. But for the node, for the Hadoop system, it will see this node has 24 terabyte of storage. Okay. Um, when is Spark going to be included in the course? Again, I sort of gave the answer, but the buffering issue, I have to give the answer again. That's fine, but you have to ask the question again. I'm sorry, but yeah, the answer for that is Spark will be included in the course. Again, as I said, it's a live course. We'll keep the course live. Okay, meaning as the new concepts come up, as they gain popularity, as more students request to add something to the course, we'll definitely add those content to the course. Again, if you are a student, you will get access to the future modules, the future lessons, the future lectures, or anything that we add to the course to to your course as well. Okay, so just to end, we the pre when we did the pre-order announcement, we said October 15th the course is going to go live, and the price of the course is going to be $149. But if you pre-order before October 15th, the price of the course is going to be $99. Okay, that is at a $50 discount. A lot of people took up the offer, and the offer ended actually midnight, and the price, as said before, went up to $149. And some people were really upset. We got so many emails, quite a few emails after midnight saying that they were trying to do it, and it went up. So for the people who are here, we want to extend the offer again. This time, the course on the website, the price on the website is still going to be $149 as advertised before. But if you're interested, just for this weekend, we are extending the offer through a coupon code. So we have created a coupon called Launch, and you can use the coupon. And I'm going to share this link with you in a bit. Okay, and And using this coupon, you can get you can get the course for $99. Just for this weekend. Again, this coupon will expire tomorrow. That is Sunday, midnight Chicago time. And the other thing to notice, there is only we see about like 30 people joining this session. So it's limited to 30. The number of usage can be only up to 30. So if you really wanted to get the course at $99, act fast. And the coupon is limited to 30, and it expires tomorrow. All right. I hope this was very useful. Along with the launch, if you didn't know about Hadoop Administrator in real world, you got to know about the course. And not only that, maybe just a little bit of a conceptual understanding of what is how to size the cluster in terms of storage, in terms of computation, and also to talk about hardware specs and things like that, right? And I also hope I answered your questions. Sorry about the buffering. There is some buffering. Sorry about that. But if you have any questions, you know how to reach us. Just shoot us an email, info@hadoopinrealworld.com, and we'll be very happy to answer. All right. Thank you, guys. And I'm going to copy this URL to the chat window. Thank you so much for joining. Okay. Thanks.